All right, guys, here is the official 5 1 through 2 review, and I'm going to go over the answers today. All right, so for the first question, there's a lot of different ways to go about getting the answer here. The first thing that I kind of think of is I'm probably just going to factor out a sign. I see sign on both sides. I'm going to go ahead and factor it out. So I'm going to go ahead and factor the sine of y out, and I'm left with 1 plus cotangent squared y. I'm left with 1 plus cotangent squared y. And the question is, does it equal cosecant of y? All right, so thinking about my Pythagorean identities. So my Pythagorean identities, you could probably just have them written off to the side. But 1 plus cotangent squared is cosecant squared. So this is the same thing as me saying sine of y times cosecant squared y. And the question is, does it equal cosecant y? Well, if I write this in terms of reciprocal identities, I get sine of y times 1 over sine squared y is equal to cosecant y. What I can see here is that one of the signs are going to cancel, leaving me with 1 over sine of y. Well, 1 over sine y by reciprocal identity is cosecant y. And so that right there is verified. All right, let's try the next question. All right, the next question, cotangent squared x all over 1 plus cosecant squared x, cosecant x plus 1 plus sine x times cosecant x. Really quickly, sine x times cosecant x is 1. Cosecant x is 1 over sine x, and sine x times 1 over it itself is going to be 1. So I'm going to rewrite this. This is cotangent squared x all over 1 plus cosecant x minus 1. And I want to know, does it equal cosecant x? Okay, so first thing I want to do here, cotangent squared x. In fact, we already kind of saw this here, but cotangent squared x is actually the same as cosecant squared x minus 1. Let me actually just show you this for a minute. I know that I have sine squared x plus cosine squared x is equal to 1. If I want to do cotangent is whenever I divide everything by sine. Divide everything by sine. And so I get 1 plus cotangent squared x. And obviously, you could just look this up on the internet too. It's fine. 1 plus cotangent squared x is equal to cosecant squared x. So cotangent squared x, if I solve for it, I get that cotangent squared x is equal to cosecant squared x minus 1. I'm going to replace it. So I get cosecant squared x minus 1 all over 1 plus cosecant x minus 1. Does it equal cosecant x? So hopefully you remember this. We did this one in class a little bit ago. I have a 1 plus cosecant in the bottom, and I have a cosecant squared x minus 1 in the top. They look super duper similar, so I'm going to find a way to kind of power reduce, or by using factoring, I can write it as the product of two things. This right here actually is a difference of squares. So a reminder, a difference of squares is something like this. A squared minus b squared always factors to a minus b times a plus b. And so if I factor this, if I think of cosecant as a squared and 1 as being b squared, this is going to factor to cosecant x minus 1 times cosecant x plus 1, and that's all over 1 plus cosecant x. Well, 1 plus cosecant x and cosecant x plus 1 are the same thing. These two quantities are factors. They are multiplied together, which means I'm allowed to cancel them out. I'm going to get minus 1 is equal to cosecant x. All right, so now what I have is just regular cosecant x minus 1 minus 1 is equal to cosecant of x. And so let's see. Oh, that was a plus that whole time. I'm about to say I was going to be a little bit confused there. So I covered up that plus sign there. The whole time it's been a minus. It's actually been a plus. So let me go and change that. Otherwise, this does not work. Okay. All right. So what I can see here is that the minus 1 and the plus 1 are going to cancel. And I get that cosecant x is equal to cosecant x. And that right there is verified. All right, so remember that this whole time you might want to either have a piece of paper or something with you so that you can make corrections before you turn this back in by the end of the day. All right, let's go on to the next one. Okay, cosine x over 1 plus sine x plus 1 plus sine x over cosine x. Can I prove it's 2 secant x? whenever I see two things added together like this, two fractions, I'm probably going to focus on trying to get a common denominator. I'm going to multiply the first by the denominator of the second, multiply the second by the denominator of the first. Okay, so what I'm going to get in the numerator here is cosine times cosine is cosine squared x. This is going to be, I'm going to use FOIL method here. So 1 times 1 is 1. 1 times sine is sine x. Sine x times 1 is sine x. And sine x times sine x is sine x squared. And that's all going to be over the same denominator of cosine of x times 1 plus sine x. Question is, does it equal 2 secant of x? All right, well, let's see what I can combine. Let me get my highlighter out for a minute. Cosine x and sine squared x, if I said cosine squared x plus sine squared x, hopefully we would know that's a Pythagorean identity. That equals 1. So that's 1. 1, and then I'm going to go ahead and continue to copy. So 1 plus sine x is 2 sine x, all over cosine of x times 1 plus sine x. Okay, so just for room's sake, I just want to make sure I'm saving room here. 1 plus 1 is 2. Hopefully that's not controversial of me to say. All right, so what I'm going to do here is I'm going to factor a 2 out. I see a 2 in the numerator. I'm going to factor it out. So I'm going to say 2 times 1 plus sine x all over cosine x times 1 plus sine x. Well, since these are both separated by multiplication, I am allowed to cancel. And so what I get is 2 over cosine of x. And the question is, does it equal 2 secant x? Well, 1 over cosine x is secant x, and so this right here is verified. All right, let's go on to our last problem. Sine squared x over 1 plus cosine x is equal to 1 minus cosine x. All right, so this problem here, there's a lot of different ways to solve it. What I might do is use a Pythagorean identity. I know some people are like, you could use a conjugate, like we saw in that video the other day. Totally fine if you use that, but it's not really maybe first thing that comes to my mind. All right, so I know that sine squared x plus cosine squared x is equal to 1, which means if I subtract cosine squared on both sides, I get that sine squared x is equal to 1 minus cosine squared x. I'm going to replace it. So I have 1 minus cosine squared x all over 1 plus cosine x, which are really similar terms. Question is, does it equal 1 minus cosine x? Okay, well, we're going to have to factor again. This right here, I want one of the factors to be 1 plus cosine x. This is actually a difference of squares again. This is going to be 1 minus cosine x times 1 plus cosine x, all over 1 plus cosine of x. So we can see here, since these are separated by multiplication, I'm allowed to cancel them. And I want to know, does it equal 1 minus cosine x? Well, after I cancel, I'm just left with 1 minus cosine of x. And so this right here is verified. All right, I think that we might have, do we have one more page? Yep, we have one more question to do. All right, if sine of x is equal to negative 3/4 and sine is greater than 0, find cotangent of x. This is a review. We've been working on this kind of problem all year. Sine of x, once again, sine is equal to opposite over hypotenuse. So I'm going to draw a triangle. In fact, I think I saw someone do this immediately when they had the problem, and I was really proud of them. All right, so we're going to draw this triangle. I know that sine has got to be greater than 0. If I think about all students take calculus, sine is only positive here and here. So I'm going to forget about these regions. I'm going to forget about those regions. All right, so I know that sine is going to be equal to negative 3 over 4, or it's equal to 3 over negative 4. So I just got to figure out which one. Well, sine is equal to opposite over hypotenuse. Another way of thinking about it, it's equal to y over r. Fun fact, r can never be negative. The radius can never be negative, and so my only option is the negative 3 over 4 option, which means that y is negative 3, r is going to be 4. So let's go ahead and find the triangle that matches that. We're going to get that y. Oh, you know what? I gave you a little bit of a typo here. This question doesn't make any sense. Great. Okay. This was supposed to be less than. Sorry. This was supposed to be less than. So let me go ahead and erase some of this. You guys can correct this as you go also. Yeah, that's not going to work if that is less than there. All right, so what we're going to do, let's go ahead and draw this one more time. The only regions where sign is negative are actually going to be here and here, so kind of like the opposite regions. So my only option is -3/4, so I need to have a radius of -3, and I want to know, and I want to write down that y is going to be less than 0 on this one. So let's go ahead and we'll say, you know what, this doesn't give me very much information at all. We'll say that this is -3, and we'll say this is 4. Alternately speaking, I think this might have had to be cosine because this also would hold true. So I'm going to accept both on this one. This one was kind of a major typo. Let's just kind of go through with it, and I'll follow both paths. Okay. So what I want to do is solve for the other one. This is not going to be a 3, 4, 5, so don't be tempted here. This is going to be -3 squared plus, we'll say, x squared is equal to 4 squared, which is going to be 16. So I get 9 plus x squared is equal to 16. And so I get that x squared is going to be equal to 7. Okay? So then I get x is equal to the square root of 7. So we're going to get the square root of 7 here. And alternately, you could have negative or you could have positive because I had a typo here. All right, so really what I want to know is cotangent. Cotangent is equal to x over y. So in this case, x is going to be square root of 7 over y. In this case is -3. Or, since I had the typo here, you could have also picked this triangle and you could have gotten negative radical 7 over 3, -3. But in the future, I will write something that's actually more helpful, like cosine or a statement that actually makes sense. All right, so just know that on the quiz, there are going to be about 5 problems just like this. It's going to be formatted almost exactly like this. So if you're comfortable with doing the verifying problems and comfortable with doing these problem types, you should be good to go. Quiz is going to take you around 45 minutes, so that means you have about 9 minutes per question. All right, that's it. If you have any questions, feel free to message me and we can set up a time to meet if you need. Happy studying.